So I'm going to show you how to add a tolerance onto a dimension and go from there. And we'll do a lot more about half and half. We'll do some drawing assemblies in Inventor, some in AutoCAD, and go back and forth. Does that make sense? In this class here. So it'll be a fun class. Learning outcomes, I'll let you read through those, but anyway, they apply to what we just talked about. So where each one of you that I know did 1040 just fine, you should be just fine, okay? The only thing I require you to bring to class is a thumb drive. Do not just expect to be able to save it onto your hard drive here, and because sometimes that fluctuates a little bit. So, but save it on at least, I would recommend 2 thumb drives. How many of you have ever lost a thumb drive?
Several just
Something you don't want to do. So if you have your work on 2 thumb drives, at least if you save at least 2 thumb drives, you have a backup. Does that make sense? Just don't always keep them right together, I guess, right? So that's the only thing that's required in this class is a thumb drive to save on. Okay? Now, I'm going to do this class, those of you who were last class heard this, but I'm going to do assignments a little bit different this semester. Okay? Especially where we are here every day during the semester. It's only for like an hour and a half or something like that, so our time is less here. We did that for a reason, you know, to break it up a little bit, because it was just a long time to be here before. That was a long class, wasn't it? And so what I'd like to do is the lecturing we'll do at the very first class period. I'm going to give you a list of drawings. And I wanted to kind of see who actually was in the class first, and know, because I know most of you in the class. Did you take it from Richard? Oh, okay. You've had a beginning AutoCAD though, right?
I had a method. I'm sorry.
Okay, so you know the basics of AutoCAD, right? You're okay. You're okay then. We'll help you along if we need to. So don't worry about it. Okay. And you'll learn a lot of new things too, okay? But what I'd like to do is, when I give you your final, all of your work is due at that time when I assign the final. How's that? Before, a lot of students would hurry and work on their other assignments and then not get their final fixed. I don't want that to happen. And so I won't penalize you on turning an assignment in late, but after I assign the final, I'll only give you at most maybe half points, which makes it not as important as your final to get them all fixed. Does that make sense? And then your final will be due the first day of finals. Does that make sense? But I'll give you the final like 3 days, 3 class periods before the end of the semester. And so, for those of you who have been in, which is only one of you, 2 of you, if you finish that final up the first day, you don't have to come the last 2 days. So you can stay for another final and go from there. And so, and the nice thing about this year is Thanksgiving is the last week in November, and you come back and there's 1 week left. And so I will give the final that day, that Monday of Thanksgiving. And so if you happen to be around on Thanksgiving and don't go out of town, you can finish the whole final up that week, and then you have a 2 week and go from there to help you out. So it works out pretty good this year with Thanksgiving like it is. So that's how we'll do the final. And again, the final will be due the first day of finals, not when we're scheduled, the first day, where I give it to you 3 days before. I think that's fair enough, right? I just want to do that to eliminate anyone from turning stuff in late. Okay, that's why I do it. Okay? Okay, let's see here. The other thing is, as we do assignments, everyone copy. There's only two of you that haven't printed yet in here. So I'll make sure you're able to print, and then I want your assignments turned in when we finish them up. Again, I'll accept them and give you full credit, but it'd be nice to get them in beforehand. That way, any feedback I can give to you immediately right there instead of waiting for feedback on your drawings. I don't want to hold them for a week or two and then give it back to you for a month and go from there, okay? And your final will be very easy. Those of you who have not had me before, don't focus on your final, okay? It's not a written final, it's a drawing final. That's all you'll be doing, okay? Basically, that's the course. Any questions? Again, you can have food and drinks in here as long as you clean up after you. And again, if you want to stay later, you're welcome to stay later. There's a class, there's a inventor class after this. And you might have to move computers, you know, but you're welcome to stay in and work during that class if you'd like to. But you have to get to work, or you can come in before this class if you want some extra time to finish up some drawings and so forth. Okay? So we'll make it pretty easy for you. Okay, so I'll work on getting the syllabus into Canvas and getting Canvas published so you can see the course in here. Okay? And then, like I say, I would like to grade your work with you during class and then implement it into Canvas right then and there so you take your work with you. Okay? And that will hopefully save some problems with if you happen to forget your thumb drive or lose your thumb drive. Okay? That you don't have to wait till the very last to print things off. During the semester, we will have a couple of makeup days. So if any of you are going to be gone during the semester that you know of right now, I can schedule the makeup days any day. Does that make sense? So if there's a day you know you're going to be gone, let me know and I'll try to factor that in as one of our makeup days. If not, I'll just choose the makeup days, and then you can kind of be gone the makeup days. Okay? Because hopefully no one will need the makeup days, but I want to have it available if you do need it. I just don't want anyone to be stressed out at the end of the semester and have to print a lot of work. And the nice thing is, if we grade your drawings the same day you turn them in, I won't lose them because I have a tendency to lose drawings and paperwork. I'll be the first to admit that. So I don't want to have you print it and have to do it twice. The one thing though is, if you do turn work in, do not turn it in 2 or 3 times. Okay? And by grading the same day, you shouldn't have that problem. Okay? Okay. So let's just go right ahead and let's get right into class fits. Okay? Is that enough for the syllabus? My cell number, if you want to write it on there. The best way to get a hold of me is through my cell number, by the way. And it's area code 435-881. 1531. And feel free to call me anytime if you have any problems, okay? Or if you need to make me extra, and if I need to sit down with you, not a problem at all. Whatever we do to make you successful is all we want, okay? Okay, so class fits. We went over this just a little bit last semester, but if you had a part that was, say, 3 inches, or maybe 2 inches. That would actually be impossible to build just with that right there. You have to have a tolerance associated with it. Some variance to build that part, right? Because you could not make that perfect with and being straight, perpendicular, and everything else. It's impossible to make. Okay? And so, same thing with class of fits. If you have a hole in this part right here, and let's say I had a shaft that I wanted to put in that hole. if I were to build a wagon or some kid's toys, I could have a lot of play, right? But if you were an astronaut going to the moon, would you want a lot of play in all your parts that are built into the space shuttle? You'd want that pretty precise with it. So class of fit is a way of specifying tolerances for different applications. Does that make sense to you? And so what we're going to do is, and we're going to find out how to put, like, we're going to have to know how to figure stuff like that out. That's what we're going to work on today. Okay? And you're going to see how easy it is and how easy it is to put on a drawing. Because as you start doing assemblies, we're going to do your first assembly on Monday. The reason it's not going to start today is I can't find it. It's still in the other CAD classroom somewhere under all the papers. So I'm going to have you work and get the class of fits down today so that we can start on that on Monday. You will find when I assign an assembly that you can actually do an assembly in one class period. Assemblies, all an assembly is a couple of simple parts put together to make a system. Versus doing one complicated drawing and dimensioning it. Assembly is very simple drawings put together. Does that make sense? And so that's why assemblies are so easy, but it's the main thing of mechanical design. Because if you design a system, you have to draw a specific drawing for every single little part, whether it be a little pin, whether it be just a shaft. That's a part. And drawing a round shaft, 1/4 inch round by 4 inches long, pretty simple to draw, isn't it? So that's a part. And if I had a cap on each end, that would become an assembly. So an assembly is just closure. And if I had to put a label on that closure, that would be an assembly too, because I'm bringing a label onto another part. Does that make sense? So an assembly is defined as 2 or more parts put together, and a part can be a label as you go from there. Okay? Okay, so the first thing we're going to do is I'm going to show you where these tables are. Okay? This little cooler over here, isn't it, in that other lab?
Yeah, I have to wear fleece here.
Oh, it feels great.
Yeah.
It was about 20 degrees colder. Okay, now, any files that I give you in this class, any files, I'm going to show you where they'll be found, okay? And so if you go hunting for anything, this is where it is. If you will. Okay, so let's just go to File Explorer right here. Okay, so here's our File Explorer. Go to PC, this PC right here. It will be in CAD Common. So anything that I share with you, anything I find on the internet and want you to have access to, it will most likely be in the CAD Common, or I'll stick it in Canvas, either one. And I'll let you know. Okay? Now, so let's go to CAD Common right now. So let's just go CAD Common here. When you go into there, it will be an EDDT right there. Don't hit that CAD Common, it's EDDT, okay? And then go under my name, lowercase, right there. Okay? That's where, this is the path that you will find any files I have for you in this class, okay? Now, what I want you to do, see where it says design work right here? Click on that design work. Okay, so here's some files that we're going to be working with during this class, okay? Now, the main thing that we're going to be working with right now is this fit right here, okay? So if you click on that fit and right-click and open with, hit Adobe right there. Hopefully that'll work. Yeah, that'll work right there. It should bring up this that says machinery handbook. Okay? Let's just check to see it.
Which file is it? It's
Let me show you. Okay, did everybody get it up? We good with that? Okay. Now, on this one here now, so you can just scroll in and make it a little bit bigger there. Come down here to where it says number 1 right here. Just see where it says number 1 right here? Okay. The class of fits that we're going to be working with right off the bat here now are going to be, we're going to be working with RC fits, LC, LT, LN, and FN fits, these right here. Okay? Now, so an RC fit is a running and sliding fit. Now, don't ask me why they don't call it RS. Okay? It's just an abbreviation. RS is an abbreviation for something different. That's why they don't call it RS. Okay? But for running and sliding fits, the main 3 that we're going to be working with is RC, LT, and FN. So an RC means that any shaft you put in a hole will slip in there very simple. An FN fit is a force or strength fit. That means that any shaft you put in a hole, you're going to have to force it, and you're going to have to press it in with a, press or beat it in or something. So you have your extremes. A very loose fit, an LT fit is that. Half and half. Sometimes it'll slide in, sometimes it's going to have to be forced in. Does that make sense? That's how these work. Now, if you look at RC fits right here, you have RC1, RC2, RC3, RC4, 5 and 6, 7, 8, and 9, right? So there's a kind of a description for each one of these different types of fits, okay? So you can see an RC1 is a close sliding fit intended for the accurate location of parts which must be assembled without reciprocal play. Okay, so you want to assemble, but you kind of want it to have that, that sound when it slips right in. You can get kind of suction noise. But an RC9 fit now is a loose running fit or intended for use where wide commercial tolerances may be necessary. So you have a loose running fit, so it'll slip in there very easy. Okay? Does that make sense? So as you design, this is kind of a standard outline for you. Now, having said all that, once you use these and start working with these class of fits, I don't ever use them. If I'm designing something, I know what I want, how I want that fit to work. And I'm going to apply correct principles because I know what kind of presses a company has. I know how much pressure you need to hold on to that. And if I know the pressure, I can figure out my own diameters. So I usually don't even use these charts anymore. I used to use them, but I don't anymore. Maybe I should, I don't know. But anyway, I want you to be aware, so I'm going to teach you how to use them though. So if you look at, and if you have to do something, so it can be not loose, but not really tight. Maybe an RC4 or 5 would work better for you. Again, the looser it fits, the easier it is to build it, the less precise you have to be. which you can produce a part cheaper than, right? But if it has to be extremely precise and you have such a small tolerance, then it costs more for the part. And go from there. So you want to weigh those different things in, okay? Okay, so you can actually read about these in here, but the main thing I want you to do is come down here. Okay, so see, like this shows you that an RC1 fit is kind of a close fit here, and RC9 is kind of a looser fit here. See how it kind of goes, how it's let out? So if you want something very tight, an RC1, loose, an RC9, something in between, you can actually get it toward which spectrum you want to go with. Does that make sense? That's what this is trying to show you here. Okay, so now, let's say that we're going to dimension this hole, and let's say that this shaft right here is 1 inch diameter. Okay, 1 inch diameter. And we want an RC, you want a close fit, a loose fit, or an in-between fit? Give me one. Close fit? Okay. Should we use an RC1 or RC2 do you want?
RC2.
RC2? Okay, so we're going to do an RC2 fit. Okay? So now, to find out how we use that fit now, we want to come down, see where it says RC2 right here? Okay, now, how do you flip again?
Try on the view,
Counterclockwise.
Yes.
view at the very top. Left side, very top, left side, view. Up, window, left to the window.
That's the window.
It's staring right at you.
I know it is.
Staring right at you.
Oh, view, I say, okay, yeah. Rotate. Let's see, I want to go clockwise. Okay. Right there. Okay? Everyone see RC2 fit? All you have to do now on this is to say your nominal size now is 1 inch. So 1 inch is between these two ranges right here, isn't it? So you come over here, RC2 is this information right there. That gives you the information for RC2 fit. Does that make sense to everybody? That's as hard as it is to using these charts. So you have a nominal size, you just pick out which diameter you're working with on that nominal size. Okay, so we're right there, and then RC2, so we're looking at that group right there. That gives us all the information we need to know. Okay? Okay, so let's figure this out now. So for an RC2, we have clearance, we have a hole, and we have a shaft, right? Okay, now, what is my two clearance numbers for an RC2 for a 1 inch shaft? Okay, it's 0.3 and 1.2, isn't it? Does everyone see that okay? Now, what is it for the hole?
Plus 0.5 and 0.
Plus 0.5?
Yeah.
And what's the other one?
0.
0. What about the shaft?
Minus 0.3 and minus 0.7.
Okay, everyone see that okay? Okay, now, let me show you how these numbers apply and relate, and every one will be the same. Okay, the only difference is when we do a force, it's not going to be a clearance, it's going to be like an interference, isn't it? Are you with me there? What is the absolute difference, absolute value between 0 and minus 0.3. 0.3. I do that right there, right? What is the absolute value between those two numbers right there? 1.2. 1.2. That makes sense? That's just a way to check you to make sure you got the numbers written down correctly. Because if they don't correspond, then you misread one of the lines. Okay? Okay, now, once you get those numbers down correctly now, all you have to do is you have to realize that these are in thousands. 6.5 thousands. So how do I change that to thousands? How do I change 0.5 to thousands? I move my decimal point how many places? 3. 2 is hundreds, remember? So what I do now is this becomes plus 0.0005, right? 1, 2, 3, right there. That make sense? So what's this one here going to be? 0. So I have 0 variation in one direction, right? So now if I want to apply this tolerance to my hole now, right now, to come up with a tolerance, I would have a lead coming off of my hole right here. Remember, I'm 1 inch, so what's my upper value going to be?
No, 3.0005.
1.0005, right? What will my lower number be? That's your tolerance right there. That's all there is to it. That makes sense? Now, let's figure for the shaft here. Okay, get a different marker here. Now, for our shaft right here. Okay, so what is this number? What does this number here become now if I move my decimal point 3 places?
0.0003.
And it's minus 0.0007. Correct? You with me there, okay? So now, what does this number here become?
0.9997.
Like that, right? That makes sense to everybody? Any questions on that, how I figured that out? So no matter what class of fit I give you now, you have a chart that has all these class of fits in here. Now, the thing about this chart now is it's all on that one directory, right? If you want to make a copy of it, or if you want to copy this onto your thumb drive, go right ahead. Okay, so you have readily accessibility.
Mike,
Yes.
who or what decides the type? You said you don't
I
use
will
it
tell you
because
what I want it to be. But then
so
if
the engineer decides.
yeah, you bet. And so you read through that list, you know, and say, well, what's the application for this? And then you decide which one to make it. And so,
Well, you're a drafter.
yeah,
But
but the engineer actually
the
does it.
engineer decides it.
And so, but like I say, you know, as I'm figuring out these tolerances, you know, I look and I know how much wear and tear on, how much rubbing is a loose fit is going to slip in there. Is it a tighter fit will it slip, you know? Is it going to different types of metals and so forth like that? All those things come into play. It's like I had a student come in this morning, you know, and every one of you know what a shear pin is, right? Like a shear pin is something that's going to break before you tear apart a transmission or something. Anyway, they build trampolines at their company. And what they're doing is they're trying to design some things that that break and have a failure rate at a certain pressure on it. Right now, that pressure is way too soon, and they're having too many rejects. They have to replace a lot of trampolines because a child, I guess, and I'd hate to do this with a child, they want that trampoline to break before a child breaks his arm. If he falls down, he gets his arm cut or something, you know, caught in there. They want that certain amount of pressure to break. You know, I'd hate to figure out that pressure, you know, is, you know, and have a child break his arm, you know. But anyway, stuff like that, you know. And so all that is built into materials you use, and stuff like that. Does that make sense to you now? Okay, so now what I'm going to do here, and if you don't mind for today, we're just going to hurry and draw this up in AutoCAD and do this one assignment. In fact, I'll give you this one and one other assignment. And that'll be all we do today until I find the assembly. Has anyone heard if we get out early today? I mean, if you feel really bad, I can find you something else to do. Okay. So what we're going to do is I'm going to do this one, and then we're going to do another one with an RC8 bit. And you're going to figure the RC8 because we're on basically different ends of the spectrum, aren't we? And then you can actually see the difference in variation. But what this is my largest shaft right here, isn't it? This is my smallest hole right here, isn't it? Well, this shaft always fit in my smallest hole.
Yeah.
So it's running and sliding, right? I never have to force it in, right? Does that make sense? That's why it's called running and sliding. Okay? Now, I like this because both these numbers are negative, right? And we're going to play with that. And I hope, no, I haven't had anyone do top class with this, so it's good. You're going to learn something very quickly here when we start applying these. Okay? So what we're going to do in AutoCAD is we're going to go in and just draw something like this right here in AutoCAD. Very simple. Okay? And then we're going to draw a shaft and do the right side view of it. Okay? So we'll kind of draw that together up in AutoCAD, and then we'll apply our dimensions to it. And that'll be your assignment for today. Okay? Okay, so just kind of put this off to the side here, your table there if you want to. Okay? And we're going to open up AutoCAD. Now this is the AutoCAD 2020, okay? So if you pick it from the desktop, make sure it says AutoCAD 2020. Okay? So, and then we're just going to do a new one. Here. Okay. But see, that's how it was. We changed it. And so they should have changed it all here. Because in the new one, that's why it's a whole semester. You're used to it. And we do that for. Okay. Everyone get that open? Everyone okay with AutoCAD 2020? Okay. Now, I want to show you one little thing that will help you. And it looks like most of you have this one. I'm going to change mine so it looks like yours, a lot of them. Most of you have it so your grid goes way out beyond this green line and red line, correct? Okay, I want to show you how to fix that and turn that off. Down here on this bar, you have your grid display and you have your snap display over here. Do you see these two right here? Grid and snap right next to where it says model or paper right here, okay? If you will put your cursor over either one of these and right-click your mouse, and then go to grid settings or snap settings right there. You see that box right there? Uncheck that box. And now your grid does not go beyond your green and red line. That's what your limits are set up in. Okay? Okay. Okay. You're okay? Yeah, sure you. Let's do this to find it. Okay, so you get there. Oh. Okay. Okay. So what I want everyone to do is just to draw a box, a rectangle here, 3 by 2, and put a 1-inch circle in the middle of that box. Okay? The what now? It's already set up for us. Yeah. So I'm just going to go there. Let's see, over 3, 2. Okay, that's a little easier to draw in a rectangle. How many of you would draw a rectangle like that? How many of you draw lines and offset it and trim it? How many of you would do it that way? So how did you draw your rectangle? Uh-huh. And then what did you type in? Yep. Yep, that's right. And now, okay, so you got a box there, 3 by 2, right? Okay, now, I'm going to change my color on this one here to, you see that a little better? Okay, how am I going to put my circle in here so it's right in the middle? Okay, I'm going to draw me one diagonal line from there to there. Why don't I need 2 diagonal lines? Because you can find the midpoint, can't you? So now I'm going to draw a circle, a center diameter from the midpoint, MID, of this one right there, and just type in 1. So there's your circle right there. Okay? Now I've got to change this here now. I'll fix it so I don't have to do that every time. Okay? There's our front view. We good with that? Yes. Okay, now, what we've got to do is we've got to draw us a shaft. So we're just going to draw this view, and now we're going to draw a view of a shaft. So how can I get a shaft drawn really easy? I'm going to copy, first of all, because I'm going to have to draw two views of it. So there, and then I could draw me a line now from this point here, which is what point? This point and this point are what points? If I type in OSNAP, O-S-N-A-P, what are those points called? Quadrant points. Check on quadrant right there. Okay? Now I can draw a line, and I can pick that point, come over here. I can pick that point, come over here. Let's make this shaft 2 inches long, okay? And offset 2. Okay? So that's what you want yours to look like, something just like that. Okay? Just make that shaft about 2 inches long. So just draw your line here and offset it too. Okay? So maybe move this line out. Okay, that's good. Now offset it. Oh, so hit M, and M for move. Hit M, enter, enter, enter. Okay. I'm going to go to offset. I type in 2. Okay. Okay. Here. And we should. I keep that to go. Enter. And then you would. Okay, so we actually have a hole, a block here with a hole in it and a shaft for our views, right? Now, just make a copy of this because we're going to put our dimensions on the bottom one, and then you're going to figure out your own and put them on the top one, and then we're going to print that out. Okay? Okay. So we're just going to copy, CO for copy, build a window around it, and copy another copy up there, just like that. So we have 2 copies. Okay. Now, the easiest way to do this is let's go ahead and, well, we could do it. Well, let's just add a diameter to it, okay? See where it says linear right here? Let's hit the down arrow key and hit diameter right there. Pick the circle here. Now, right now, I can't get it to move out, can I? So just click there. Then click it again, grab the center point, and move him out, and put him maybe about right there. That make sense? Everybody get that dimension turned out there? Yeah, just put it right there. There you go. Okay, you only need 1 copy of those.
Oh,
So there'll be 2. So you can erase 1 set of them. Okay? Okay, now, we need to make this. This is our hole, so we want to be 1.0005 over 1.0000. Does that make sense, everybody? Okay, so now what we're going to do here now is click on your dimension. Then right click. Okay? Now, go to properties right here. Go to properties right here. Okay? It's going to bring up these properties. Now these properties are exactly the same properties in your dimension style box when you set up your dimension style. And we get this box up here, okay? We good? Okay. Now, if you'll scroll down here, see remember, and then we had lines and arrows, there's text, there's fit, primary unit, alternate unit, and tolerances. You want to go to tolerances. Okay, so we want to see tolerances here now? Yeah. Okay, now, the third one down where it says tolerance, let me pull this out here just a little bit here. See where it says tolerance display right there? Third one down? You come over here and click in that box right there and hit the down arrow key. You see none, symmetrical, deviation, limits, and basic, right? Okay, what we want is this symmetrical around 1 inch? If it was +3 and -3, it'd be symmetrical, right? This is plus something and -0 something, right? So it's not symmetrical, is it? So what we want to do is we want to see what limits are right here. Okay? That makes sense? So click on limits. At least we have them in 2 rows because we need 2 rows here, right? Now, what is our precision? See where it says tolerance precision? How many decimal places do I need? 4, don't we? Okay.
Hey, Michael,
Yes.
I can't find the properties for some reason.
Did you right click it?
Yeah.
Should be the very bottom, second one up. Okay. It's escape.
Okay, sweet.
Now scroll right down to tolerances. Okay. Scroll right down to the very bottom tolerances. And you see the third one down that says tolerance display. We'll click this box right here. Now hit the down arrow key and we want it. Okay. Now our precision is 4, so that's only going to get 4, right? Now we're going to add some other numbers in. So hit for that tolerances, see what it says none right there, click on there, hit the down arrow key and hit limits. Okay, now you at least got it stacked up. Now we just got to get those numbers filled in. We good? Okay. Now, right here now, do you see where it says the tolerance, the lower limit, and tolerance, the upper limit? Okay, what is my upper limit tolerance? Okay, so it's going to be 0.0005, right? What's my lower one? 0.0000, right? And guess what? Lived in for us, didn't it? That's how you had tolerances. Okay, and then just hit enter or escape. There you go. So there's your tolerance right there. Okay. There. Okay, we get that okay? Now, the next one, we got to put it on the shaft, so we're going to dimension that circle now and come out and do the same thing, but we're going to make that have to equal this right here. Okay? So, let's come in here with the diameter here. Come here. Okay. Now I'm going to click on it and go to properties now, okay? And we'll scroll down to the tolerance. And again, I'm going to hit limits. What's my precision now? 4 decimal places, right? Okay, now what is my lower limit right here? What's our lower limit for our shaft? What is it now? 0.000, our lower limit. 0.0007. The lower and upper are switched around if you read in your documentation right. I wish they'd fix that, but they won't. Okay, that's what I want to get at. So for right now, you're just one step ahead of me. Just type in 0.0007 for your lower limit. So for your lower limit is 0.0007. What about your upper limit right here?
That's interesting how we don't need to include the minus sign.
Well, now, hold on now here. Okay. Now, is that right? No, it's not. I'm building mistakes into it, is what I'm trying to get you so you won't make mistakes. Now, when we put a tolerance on a number, when they first started with tolerances, it's like a plus and a minus, right? That's the standard way to do a tolerance, right? That we're all used to. So we're used to some plus or minus number, right? Now, what do I have here? Both of them are minuses, right? So the top one is out of sync, right? So what do I have to do to make that into a minus? I put my minus sign on the one, right? Does that make sense? So if I go back in now and edit that and go to properties, so now if I come back into here now and go to properties and scroll down here now, on that one right there, if I put a minus right there, now it's correct, isn't it?
Yeah.
So if these were both pluses now, I'd have to put a minus on one of them, right? Because one has to be plus, one has to be minus. That's just how the standard was set up to begin with. Okay, so now, once to get used to it, I recommend to students to write it out like this, figure out what you want your tolerances to actually be, and then make sure you can make it look just like what you figured out. Does that make sense to you now? So that's why I purposely had to make that one mistake, just to show you that, you can't just type just the numbers. If it's out of sync, out of plus or minus, you have to put a negative on the one you want to change to the correct sign there. Okay? So what I want you to do, and this is all I care about, on the top one now, or your next set, I want you to figure it out for an RC8 set and dimension those two, and then I want you to compare them. Does that make sense what I'm asking you for? And you can kind of see now how to go in and add a tolerance and go from there. Okay? Okay, so now, let me show you how that works. Okay, so right now, we want this to be in that corner right there, right? Our top and bottom, right? Okay, so our top number is right now is a negative 0.0003, and our bottom number is a negative 0.0007. Which one's out of sync? You know, it should be plus, minus. This one's out, isn't it? It should be a plus, but it's a minus. So we multiply it by a what to make it a plus? You change the sign, right? So now you just change it on the screen, right there. And right there, put a negative right there. That's it.
So you did the negative on
On the one that is the difference. Now, if these were both positive, if you had a positive 0.0003 and a positive 0.0007, which one's out? This one here, right? Plus, minus. So we have the negative on the bottom. Because, see, it should be plus or minus, right? They're both pluses, right? I'm going to make that into a minus, the bottom one, don't I?
So is there difference still?
Yes, yes. But that's why I want you to figure that on paper first, so you get used to that sequence. And so you say, because where you had that one up there, and you had right there, you have those two numbers, you can make sure they lined up with that and get it right. Once you do it a few times, you won't be able to put it on. You can just have that right in from that chart right there, can't you? So I just want you to get used to it. Okay? So once you do that, figure it out for an RC8 bit for 1 inch, and then just make a print, and I don't even care if this one's on a title block, okay? Now, the printer in this room is the same as the printer in the other room. It's a 712 printer. It should print right there for you, okay? Just make sure your name's on it, and that's all I'm asking you for today. And we will have your first assembly for Monday to get going on, okay? And there will be a class of fit on the assembly on Monday. Okay, so you will want this same class of fit here. You'll be using this quite a bit during this class. Okay? And let's go from there.
If you want to put it on your title block, if you have one, you can, just scale it up a little bit. Is that what they are?
I don't know. Well, I believe so.
Okay, that one's right there. And then you have a negative 3.5, which should be 7, that's right there, and 5.1. Yeah, that's right.
Thank you,
So
Mike.
you can see that you actually proved to yourself that an RC2 is a lot tighter than an RC8.
Right, yeah, which we see in
that thing that goes off like that. Yes, exactly right.
Right.
So that's that's all I want printed out.
Okay.
But you can see you really don't have to do all that figuring if you understand, you know, this plus and minus. If they're both the same signs, one has to be a minus.
Well, right. It's just in the language. It says lower, which means the number is going to go down. So it's just just a way of
exactly
thinking.
what I'm trying to get you to
And when it
see how
says
that-
upper, then
Yeah.
you're like, I don't want the number to go up. I
That's
don't want it to
exactly
go
what I'm
down.
trying to get you used to it, so you know what it has to look like, and that you can start getting that, you know, formatting. I wish they would say upper and lower, not lower and upper.
Right.
To me, that would make a lot more sense. And then I'd know which ones to automatically put the plus and minus on without having to read it.
You want us to print it down?
Yes, if you would just put your name on, right, you know, name on that, go to.
Sarah, if it just prints right there, now.
That's fine, that's fine. That is perfectly fine, this person signing, okay?
Mike, do you want the scale on this to be,
Don't even worry about the scale.
or enlarge it for easier reading?
Just enlarge it so I can see it, yeah. Yeah,
Yeah.
make that a little larger.
Oh, I also need to use the dimension layer for these things.
Okay, take this off first. And then exit, and you don't see it, the drop. Yep.
Which one is it? 712, the printer?
Now, the shaft, this is one minus. You have to change these to thousands now. 0.00045.
So 1 minus 1.
Yes. That makes sense? So your precision now is going to have to go to like a 5 decimal place. Precision, isn't it? So, okay, let's look at this now. Let's see. Let's just sit right here for just a minute now. Okay. Can I scribble on your drawing? Let's see here. You got your name?
Yeah.
Okay, come here just a minute. Okay. Can I come over here? If everyone wants to come here, just I think there might be a little mistake we're making.
Yeah, really.
Okay, so we're going with an RC8, right? Okay, no, maybe you did it right. Okay, so in RC8, we have our clearance, we have our full, and we have our shaft, right? So what is the clearance? So 4.5, or so 3.5 and 0, right? So 3.5 and 0. What about the hole now?
No, that's the clearance. 4.5, I can't adjust the clearance. This is the whole.
Okay, yeah. Okay, so give me the clearance again.
4.5.
Okay, 4.5 and 10, right? Now what about the hole?
3.5
Okay, plus 3.5 and 0, and the shaft is
negative 4.5,
negative 4.5 and what?
negative 6.5.
6.5. Okay, now, what we have to do is we have to move our decimal point 3 places, right? So this becomes negative 0.00045.
Oh,
So what's my precision going to be set at this time? 5, yes. I have to show 5 decimal points, don't I?
But the problem is you won't get 1, 2, 3.
But it's 4.5. Oh, wait a minute. You're okay. You're right. So it will be 4. I'm sorry.
But I made a mistake, I looked at the wrong.
So 1, 2, 3, and then this would be 0.0065, right? 1, 2, 3.
Right.
So your precision still is 4, yes. Sometimes the precision will go up, it'll be 5. If you have like this one right here, you move that one, no. Some of them will be 4, some of them will be 5, depending upon the precision. You might have 0.004 or 0.1 or something like that. And so just be careful with that, okay?
I gotta fix it. Fix it. How did
Compare
I?
your two, how's that? So you've got 1.0035999. So someone's wrong. Who's wrong? These are switched around, Brian.
Yeah, I looked at the wrong column.
That makes sense? And so you guys go back in, because remember the lower is on top of the upper now. Remember they're backwards in there. So I think you may just put them to the wrong one.
So this.
The numbers, yeah, these just need to be put there. You got the right numbers.
I think mine should be the bigger one.
Okay.
Oh, no, I got the whole right.
Okay, yeah.
51.
Yeah. Yeah, you did yours wrong. You were right when you said you were wrong.
So.
So you see how it helps to do it on paper first when you get the system going, right? So, good, very good.
Yeah, so, yeah.
So just pull, yeah, maybe that's the way to do it. So the lower limit would be, yeah. Okay? So, but the whole concept was to let you see how that kind of works there. And the best way is to pull it out so you see the whole abbreviation, the whole name instead of, lower limit, you don't know if it's upper, lower, and so forth like that. Yeah, put them right up there on my desk, and that's it for today, okay?
Sweet.
That's only 25 minutes early, isn't it?
Yeah.
Not too bad.
I'm gonna be here all day anyway, so.
So you in 2710?
I have a welding class.
Oh, you have welding, okay.
And then I have the machine. What's that? 10. It's terrible.
Joe Clark.
Oh, nothing, no.
He can be nice. I'll put it that way.
They're similar, just different.
Yeah, thank you, Kurt.
Spider-Man and Venom, or what are we looking at here?
Joe is very nice, very knowledgeable. Very knowledgeable.
For the first day? Yeah, I'll bring in the money, definitely. Brandon.
So did you have, is this for manufacturing processes or what?
Manufacturing, well, this for welding.
Oh, so you took welding, huh?
Yeah, last semester.
Yeah, I did.
How did you enjoy it?
One day I didn't wear the proper shoes out.
It kind of burns holes in clothes, doesn't it?
Right number.
Okay, well, that's your new one, right?
Yeah.
Okay, so, the lower one then. Yeah. It's that crystal ground, right?
later.
No, yeah, I have something
That was right now?
like, we have them making t-shirts. But I just bought one. Just a little one.
Like what kind of?
Big. And so I'm doing restoration.
Yeah, I was on that.
Good stuff.
Oh, Brett, you found it okay, so if ever you don't find the printer, Jim, turn it off and reload it, and it'll,
Hopefully.
yeah.
So you just want our names on this?
Yes. Yeah. You can hand write them on this person, I don't care, or you can put it on in the chat. Okay, so all you have to do now is go to, type in EDDT. There you go. And then you start point two, hit enter. Hit enter again, and start typing. Hit enter. There you go.
What do you want these?
Just on the front there, it should be, I think Brandon put this up there.